Good morning, parents. I'm Mrs. Shepard, and I've heard from at least one of you that there's some problems with understanding the area model. So I'm going to do the example from our anchor chart so you can see step by step what I do, and then I'm going to also compare it to the old way, how we know it, the standard algorithm. So you can see that the same steps are taking place. It just makes a little more sense conceptually what we're doing. So our problem is 784 divided by 6. Maybe we have 784 pencils and we want to put them in groups of 6 to distribute to students. How many students can get a group of 6 pencils? So using the area model, we say 784 is the total area of this rectangle. And we know that 6 is one of the factors, and we're looking for the other factor. So in the standard algorithm, you can see that it's kind of similar. So what we do in the area model is we stretch out our number into place values. So 700 plus 80 plus 4. And we put that into a rectangle to be our area. So this is equal to this, it just looks different. And one of our factors is 6. Wherever, I've taught the kids, wherever you have an addition sign, and this is the same from our multiplication area model that we did a few weeks ago, we put a line. So my first step is to expand the dividend inside the rectangle, and that's what I've done. My next step is to underline the first digit. So I'm going to underline this first digit. What times 6 can give us a number that doesn't go over 7? Well, I know that 6 times 1 equals 6, but 6 times 2 equals 12. 12 is over 7, so I have to stick with 6 times 1. So I'm going to put the 1 right here. I know 6 times 10 equals 60, and 6 times 100 equals 600. So 100 times 6 will give us a number close to 700 without going over. 700 minus 600 is 100. So I'm going to come over here to the standard algorithm. We say 6 goes into 7 one time. 1 times 6 is 6 with 1 left over. This is actually 100 left over. And here we show that we have 100 left over. Our next, we did using multiplication, what times the divisor equals the area, or a number close to it without going over. Now, step 4 is add the remainder to the next area. So this is why I have an arrow going over. 100 plus 80 equals 180. Repeat steps 2 to 4 until the remainder is smaller than the divisor, so smaller than 6. The standard algorithm, our next step is to bring down. And that's what we did here. We kind of brought down the 80 with the remaining hundreds. So I go back to step 2, underline the first digit. What times 6 can give us a number close to 8 without going over? I can go back to this chart. 6 times, going to 180. This is the digit I need to underline. Nothing times 6 will give me 1. What times 6 will give me a number close to 18 without going over? 6 times 3 equals 18. 6 times 30 equals 180, which is what I have. So I know 3 times 6 will give me 18, so 3 times 30 will give me 180. My step says to subtract. 180, take away 180 is 0. Bring my remainder over here, add 0 to 4. 4 plus 0 is 4. Here, 6 goes into 18 3 times. 3 times 6 is 18. Subtract 0, bring down. So I'm still at the same spot. What times 6 can give me a number that doesn't go over 4? There's none. The smallest number times 6 is 1, will give me 6, which is over 4, so that means 0 is my only factor that will give me a number that doesn't go over 4. 0 times 6 is 0, and just like before, I take my remainder, and this time it came out of our area rectangle. So that means that it's a remainder of 4. We can no longer divide it into smaller parts. So wherever there's a line, we have an addition sign. 100 plus 30 plus 0 equals 130 with a remainder of 4. Here the same thing. 6 cannot go into 6 cannot go into 4. 0 times 6 is 0. Subtract. Remainder 4. So I hope that helps to explain. If you have any questions, please do not hesitate to email me or call or come by and we can work on it some more. Thank you very much for your patience and for helping your children learn Common Core math.